Good morning, Logan. Welcome back to another exciting chapter of geometry from home. All right, so what we got here is properties of rectangles revisited. We're just going to talk about what it means to be a rectangle. There are three characteristics. Number one, all the angles are right angles. All right, all the angles are right angles. Number two, the diagonals are congruent. And number three, it is a parallelogram, which means everything you know about parallelograms holds true for rectangles as well. Our first example is that we have a rectangle, and the rectangle has its diagonals intersect at point E. The diagonals, in this case, go from A to C and B to D. Now, where they intersect right there, we're going to call that point E. So I'm going to write an E right over here at the point of intersection of those diagonals. Next, it says, given that angle ECD, so ECD, this angle right here is 19 degrees. So I'm going to write a 19 degrees right in there. I need to find the measure of every angle. All right, so there's a lot of angles going on here. So I'm going to start off with this angle here. These two angles I know form a right angle because of the first property is that all the angles are right angles. So I know that this angle right here has to be 71 because when you add 71 to 19, you get 90 degrees. Next, since it's got statement number two, since the diagonals of the rectangles are congruent, I now know that this and this and this and this, all those pieces, all those parts of the diagonals must be congruent to each other. Now that gives me an isosceles triangle right here. So I have an isosceles triangle right in there. Now isosceles triangles have two properties. The first actually has one property, that two sides are going to be congruent, but it has a theorem associated with it that says that the angles opposite to those sides must also be congruent. So I now know that that's 71 over there. But since angle B, all of angle B, ABC, this whole thing is 90, this angle here must be 19 degrees because these two angles have to add up to 71, have to add up to 90. But because this triangle is an isosceles triangle right over here, I can use the isosceles triangle theorem again, which means that this angle must be congruent to the angle opposite to its congruent sides. And then I know that this angle over here will be 71 because angles of a rectangle must be 90. And then this is an isosceles triangle, which means this must be 71, which means this must be 19. Now it looks like I found all the angles, but we have we have four angles where angle E is located. So what I'm going to do is I'm going to take this isosceles triangle right here, which is 71 and 71, and I'm going to find this third angle, the angle inside towards the center of the rectangle. So 71 and 71, they add up to 142. So we get 142, and the remainder of that has to add up to 180. So I'm going to take that away from the 180, and this gives me 38. So I now know that this angle is 38 degrees. But because of the vertical angle theorem, we know that the angle across from it must also be 38 degrees. We can do the same thing with the bottom triangle, or we can say that these two angles here, the 38 and the angle next to the 38, must form a linear pair, which means this angle down here has to come out to 142 degrees. 142 degrees. But then that would also mean that this angle would have to be 142 degrees. So I'm going to get rid of that E right there. So we'll get rid of that E, and we'll just write 142 degrees right in there. And now we know all the angles of the rectangle. All right, last thing, I'm going to give you guys a hint for the problem on homework tonight or today, is that since all the angles are right angles, including an angle kind of looking like that guy, that would mean if I was to draw the triangle right here, this would be a right triangle. Now, right triangles hold a lot of information in them. They also hold a lot of equations. One of those equations is Pythagorean theorem. You could say a to the power of 2 plus b to the power of 2 equals c to the power of 2, where c is the hypotenuse, also known as the diagonal. Okay, just keep that in mind for one of the problems. One of the last problems. All right, if you guys have any questions, go ahead and text me. You can also send me an email, or you can hit me up on Google Classroom, and I'll get back to you as soon as I can. All right, take care and keep your six.